Uh, Good morning, afternoon, everyone. My name is Jay Singer-Dumars, and you are attending the SIG Azure meeting on Wednesday, January 24th, 2018. If you want to follow along after the fact, the agenda and notes are available at bit.ly/SIG-Azure, and you can look there and see what the outcome of this meeting was. Basically, what we're going to do is just run through really quickly what the work in flight is and talk about if there's anything that we see as a risk for our 110 cadence and go from there. So without further ado, if you could sign into the agenda, that would be great. So I'm going to paste a link to that in chat so you've got it handy. But go ahead and put your name and company there and we'll make sure that you are represented. And so without further ado, let's talk about our 110 priorities. So I want to give a big shout out to Cal. Thank you so much for running the prioritization planning when that happened last time. Unfortunately, I had a really major family crisis at the same time, so I wasn't able to make it. And I do sincerely appreciate your help getting that organized. So from that list, basically, if you look in the agenda, we have a list here that's based on priorities. So all the P0s are first, P1s, P2s. So what I'd like to do is just kind of go down the P0 list here to start and see if there's anything that we have to update. Cal, I know you have workers in your house, so it might be kind of noisy there. Do you feel okay just running through these things real quick, or?
Yeah, so let me go through this. So Azure KMS, the work is started. This is the gRPC implementation, not in tree. Work is started and we're on track to deliver on 110. I do believe we'll deliver a lot earlier than end of Feb, which is the time that the cutoff for like code freeze and stuff like that. So it's on track. I think by next iteration we should have at least a basic code running for KMS. This is using Azure Key Vault. As for the VMS as support, same work has been actually in progress for a very long time. Today you can have the you go to ACS engine, create a cluster and just change the availability profile field to VMSS, and that will give you a cluster using VMSS. Because of the major change that this implies, we're still testing everything, and this again should be ready by 110. The autoscaler work is a bit stagnant right now. It's slower than what I expect it to be. However, let's not change the fact that it's not gonna make it on 110. It will make it to 110, maybe just a little bit late, more working hours towards the end, and so on. The app gateway. So the idea is to use Azure Application Gateway as an ingress controller. This is stagnant actually, and it's not moving, and we're looking for help. If anybody has some cycles to spend on this, please just reach out or just start the work and let me know. Out of three provider.
Sorry, I have a question. Can you share user story how it's going to be implemented?
For the app gateway?
Yeah.
So there is nothing really happened other than exploration. So
okay.
So if you decided to pick it up, you own the design, you own everything.
No, I don't know. Decide to pick up. We get it's honestly, right now we have load balancer with HA proxy. It works pretty well, but we have strange requirement from security folks. They would like to use basically firewall, what application gateway has.
Yeah.
And we are pushing back very hard because there is no Kubernetes integration. I just wonder if you guys trying to implement, I'm just curious how it's going to look like at least. So this is what only my concern.
So how it will look like is exactly how App Gateway works. So App Gateway, the feature you're interested in is the traffic termination at the gateway level. right?
You mean TLS? You mean TLS and firewall? Yes.
All the traffic is terminated at the edge gateway, and then another set of traffic flows into the cluster. That's a basic feature of gateway, and as you said, a lot of people are interested in this for security, compliance, yada yada yada. And this is what we have in mind. How it will look like is, from a Kubernetes perspective, is you will create an ingress resource. That's the use case of type Azure App Gateway, annotated in some way, and then this will be created for you. Okay. Similar to how the Nginx work.
So basically, I will need to deploy something kind of like whatever, like we have, like, I know, app gateway controller. He will basically manage that, and after that is going to be the usual like ingress resources, nothing special.
Yes.
Okay. Okay, looks good. Yep.
That's the basic idea. That's the basic use case we have in mind. That's described from Azure point of view and described from Kubernetes point of view. At the end of the day, there will be an app gateway in your resource group running in your VNet, right? There will be some, obviously, when we talk design, there will be some ideas around, because the app gateway, the dedicated, is quite expensive. So should one or not? That's going all to be a discussion of how we want to implement this and what kind of, how can we deliver this use case to the user. But as you said, there is a bit of design that needs to, as you can tell, there is a bit of design that needs to happen.
Okay.
All right.
And when this happens, I would love to see us write a really cool blog on this. I think this will be a great pattern for people who have been struggling with a quality ingress and don't want to necessarily go with something that is outside the Azure ecosystem.
Yes. So the way I see it, based on my interactions with customers, partners, users, and everybody is trying to use the Kubernetes on Azure, is the like highly strict, compliant regulatory environments such as banks, financial institutions, and so on. This is a typical request from security people, security teams to devs, is terminate the traffic. All the traffic needs to be terminated. And I think App Gateway delivers this quite nicely. So we'll see. Okay, let's go back to the document. Okay. V1 tree provider. The last time I described this, I went through it and I said what we have right now is a job that synchronizes the entry provider, wrap it up in a separate executable, in and out of tree provider. The only reason the code is there right now, it's on Azure username. The only reason it's private is we're still working through the legal issues of licensing and you know, when you put something under Azure, it goes Microsoft, and there is a bit of our legal team needs to look at that.
I have an update for that too, and that's that it looks like we're going to have a top-level Kubernetes repo for this instead. So we're going to have the ability to bypass all the legal crap and also inherit the CNCF CLA, and also all of the automation from Prow and Tide and whatnot. So we basically are going to have a tremendous leg up to make this happen faster and more efficiently, and also continue with contributors working on this in the same way they do core Kubernetes. So that's really good news.
Yes. So I'm happy to have you here, man. And I'm happy that you're actually carrying all of this for us, because this is hard. This is tough stuff in terms of processes and so on.
So in terms of the code itself, we're going to have the breakout meeting in about an hour. Is there some code that we can plop in there if we get a repo to start playing with, or?
Yeah, but the code right now is in Azure username and it's private repo.
Okay. So you and I, we can sync offline and talk about how we get a prototype up.
Yes.
Okay, great.
The good news is the job runs almost every day, if I remember correctly, which keeps the Azure out of tree provider exactly as in the entry provider.
Oh, good.
So if you decide to move to like actually use this, what you will get is almost everything inside the tree provider, with the fixes, with the features and everything.
Cool. That's great news. Thank you.
All right, so moving forward. The Azure Disk Encryption, still in design phase, right? The idea is to support encryption for your disks when you mount them on nodes, right? What's happening is the basic plan we have in mind is there will be a key vault anyway with every Kubernetes cluster on Azure Key Vault for secret management, for KMS. So we want to use this Key Vault for disks as well. I cannot really tell if it will make it up to 110 or 110x, but it's moving. Maybe next time I'll have more update on this. Explicit MSI, this is, all right, let me walk through what Explicit MSI is. Today, when you use Kubernetes, Kubernetes on Azure, you have the choice of using either a service principal or something called MSI. A service principal is you go and you create similar to service account feature. You create a service account, you give it a username and you give it a password, and then you go have this username and password as a file configured in every Azure node and master, every Azure Kubernetes node and master. This works really well, but as you can tell, it's not exactly the best way to do things. So Azure has this feature called MSI, which is Managed Service Identity, where each node gets an identity, and then you can grant access to this identity on Azure resources, such as ARM and so on. This again works really well, but you have identity per node, which really interesting because right now you have to grant every single node. If you have a float cluster that goes up and down, scale up, scale down, this is not going to be easy to operate. The new iteration of this is something called Explicit MSI, where you can group the entire cluster or parts of the cluster, if you will, if you want, into an identity. That identity becomes what you grant access to or revoke access to. This work has been started and it's on track for 110. It will be a simple change on the cloud provider code that says, all right, use AMSI, and that's it. All right. Now let's go for the next one. Questions?
Sorry, one more question. Like this is MSI stuff is going to work like all Azure stuff, or is it going to work only for like US? Because like we having the biggest problem today. We have like one in US, everything works, and we go to Germany, our features doesn't work or doesn't exist at all. I'm just curious, like this MSI stuff is like global everywhere, or is it just experimental?
I understand your question. So Azure as a cloud is separated to what we call Azure Cloud or Sovereign Clouds. Azure Cloud is what you get basically everywhere. This is North Europe, West Europe, the data centers we have in US, Canada, Brazil, and all of these places. And then there is the sovereign clouds for a lot of reasons. We're not going to go into why we have them, but they are clouds that are not directly managed by Microsoft. All right? Those are the clouds in US government, the one in Germany, the one in China are the three main ones. The feature deployment starts from Azure Cloud and then goes into Azure, the government cloud and the sovereign cloud. The reason behind that is it takes time to get things over there. We don't do things directly over there. We do it, somebody else is watching us and all of that. So the feature we're talking about, the rule of thumb is talking about Azure Cloud. Will they be in Azure sovereign clouds? Yes, they will be, but they will take more time. And the reason behind that is the longer deployment process. Can I tell you when, or the rough difference between, let's say, on January 1st, I deployed the feature on Azure Cloud. Should I expect it by February 1st? I cannot really say that because it depends on the feature and the infrastructure it uses. I'm sorry, I don't have a lot of information on this, but it is what it is. I'm sorry, man.
Okay.
Right?
It's okay. Thank you.
For that particular reasons, we don't remove feature. This is one of the reasons we do that. We keep that in mind. We don't remove features out of the cloud provider. So the service principal is still supported for you to use for sovereign clouds until the newer feature hits the cloud you're interested in, such as Germany cloud. Make sense?
Yeah, but again, like my only concern is like I know like my security guys, they a little freak out that we have on disk like all these service principals, and they like we're keeping them in touch for now, but they will like soon like freak out like hell. That, oh, you have on every host you have service principal for like all Azure stuff. It's like this is their concern.
Understood. I
Yep.
completely understand where they're coming from, and we're working hard to get this.
Yep.
Through. All right, going back to Windows CRI, I don't have info. All right, I need to go check out what's happening over there. OMS is the same, right? The Azure Storage Fuse driver is stagnant, is stalled, and the schedule modification is stagnant and stalled. The rest is basically still as is. The updates are on the bugs themselves. That's it. That's my quick update, which is 19 minutes of the call.
Good job, Cal. Okay, great. Well, we don't necessarily have any other updates. I think this is pretty thorough. Is there anything that anybody else wants to add in terms of things they want to talk about? And otherwise, we'll just give you 10 minutes of your day back.
I wanted to mention that there's a statement of work being submitted from CloudBees, I think is who's actually going to be doing the work, to start adding tests for mainline Kubernetes that run we run the end-to-end tests on Azure, and we're also going to be doing this for Windows. So we'll probably start coming into this meeting as well as the SIG testing meeting and giving updates around that. So there's some movement happening there.
Cool. That's great. And then I assume we're going to publish those results up to test grid in Kubernetes?
Yeah, so the statement of work has that as part of the acceptance criteria. So it will run through just like the GCE tests do now, or GKE tests, or sorry, the GKE tests do, and all that. That'll be published the same way. And part of the things I'm going to help work on is also being able to make sure these are easily runnable locally, right? Just like the ACS engine tests are and things like that. So customers can take advantage of using these as like a diagnostic tool, potentially.
Fantastic. Anything else?
Not from my side.
So I have one issue that I brought up in the window there. I don't know. I just wanted to ask you. DNS labels or ingress.
David, I lost your audio there for a minute.
Yeah, I'm just wondering if anybody has the
Anybody has any updates, or this is on anybody's backlog for the DNS labels annotations?
This?
My audio is going nuts over here. Sorry, but
I think so I am not sure I understand the issue. So you want to let's say you want to give that specific DNS label. And
yeah. So when you have the ingress controller automatically creates a public IP with the load balancer, right? You want to be able to assign a DNS label to that IP. There's a PR, and I couldn't find it on the call here, but there is a PR that enables the DNS label
Yes.
for services. But for ingresses, I didn't see it.
I'm not sure I understand. The ingress itself doesn't get an IP. Usually you have a service that points at the ingress controller, and the service just gets an IP.
Yeah.
Are you talking about public IP?
Like ingresses don't get allocated IPs.
No, but when you deploy an ingress controller, you get IPs and you create DNS.
Yeah, but that's just through a service object like any other service.
So let's frame the requirements. So the question here is, you want to give a public IP assigned to a service a DNS label. That's the first requirement, right?
Yeah, so I have an ingress controller. I have a bunch of services which are not. I don't want to be directly exposed and nor have a public IP. I have one public IP from an ingress controller. I want the IP that's popped up from when the ingress controller is created to actually have the DNS labels.
Yeah.
So let's solve for that one step at a time. The first requirements is to give a DNS label to service that's out there. There is a PR. I know it's out there because I've seen services.
It is. And I actually tried that. I put that annotation on there, and it didn't.
Yes, because that annotation is expected to be on a service, not on an ingress controller.
Exactly. Yep.
Now, if you want to have one ingress controller that carries multiple FQDNs or DNS labels, basically, what you do is you use the external DNS project. All right. So what we do is actually we do that in AKS all the time. You deploy your ingress controller just as you deploy any other ingress controller, your favorite type of ingress controller, be it Nginx or Wistia or Envoy or whatever soup of the day is. And then you create ingress resources, add a DNS label to these ingress resources, and then deploy your ingress external DNS controller that picks up these labels or this annotation, and then go provision DNS records for them.
Okay. I'm happy with a single label.
Yeah. So the idea
I would
is
ideally like it to where it's as simple as the service one, where I can just add an annotation and then the one label is popped up at a time, so I don't have to go through all that.
You need to understand that if you want to do that, the easiest way to do that is your ingress controllers. When you deploy an ingress controller, you deploy a service with it, right? You give it an IP.
Yeah, David, as part of your ingress deployment, you should be deploying a service object. Like an ingress itself doesn't get an IP; those are just random pods running. So there's a service there that's abstracting the ingress to the ingress controller, which you should just be able to put your annotation on.
So is your case that you want to share the IP for this multiple FQDNs, or is this separate IP for all FQDNs?
Just one IP per FQDN. So the thing that's nice with that is to have the attached to the traffic manager, because then that allows. I mean, that's one option, right? So you could throw the traffic manager, use the public IP, which requires DNS label, and then that way that provides a mechanism for testing and production. It also provides a mechanism for kind of gradual roll off of individual clusters.
Yes, but that can be solved as Cole said.
Okay. Yeah, I'll have to look in. I'm using the ingress controller chart, the Helm chart. I probably just need to dig into that and find the service and try and add the annotation there.
Yeah, and also again, if you take a look at external DNS, I think if you even allocate a service with like labels and create like this service like load balancer, I think it will create DNSs for you as well.
Yeah. So in order for you to, there are three things you need. You need ingress deployment, you need an ingress resource object, and you need a service.
Yeah.
Now, the service that exposes the ingress controller needs to have a DNS label that will give you one DNS label for any IP or any route exposed by this ingress controller. If you need different FQDNs assigned to the same ingress controller, then you need to deploy external DNS, the Encryption project, which have Azure support and it's actually quite stable, and add the DNS annotation or FQDN annotation on your ingress resource. And that's it. That will give you exactly what you need.
Yep. Yeah, I'm good. Thank you.
I'll respond to the link you said, and I'll just describe it again for people who have the same question to just carry it on.
Great. Thank you, Cal, for doing that. Anything else before we adjourn? All right, everybody. Have a fantastic rest of your day. We made it through another meeting. Woo! I'll see you next week. And don't forget, it's now we're doing this every week because it's so much fun. We have to do it every week. I'll see you later.
Take care.